Thank you. Thank you. Yes, my name is Fabrizio Monaco. I am from TomTom. I'm a product manager of the automotive HMI. That is the user interface, built, of course, with Qt, that gets embedded into the cars. So my team, the team that is developing the HMI, is composed by more than 30 people. Most of them are based in Taipei, and it's really great. We've been working together and also with Qt since 4 years. So what I want to talk a little bit about with you today is how we try to fight driver distraction within TomTom and when developing our HMI. So a quick look at the agenda, a quick introduction of what we do. You probably know, so we can go pretty fast on that one. What is our product portfolio from TomTom side? How we try to fight driver distraction. What does it mean, fighting driver distraction? What are the technological trends that we are seeing in the automotive space? And I will give you some insights on how our automotive HMI is built. So some more details. I'm an engineer, but I'm working as a product manager. I will try to also give some technical details and also to provide you with one concrete examples. That is how we built our scalable keyboard. So our vision as TomTom is that we believe in a connected, automated, shared, and electrified future. So these are the 4 main trends that we see in the automotive space, and we want to embrace all of them. And we also believe in a world where the drivers will interact with the smarter cars and the smarter infrastructure. It's really a dream. It's really like the future. So how do we break down what is our mission as a company, as a navigation company? So as a navigation company, we want to help OEMs, so there are car makers, but also tier 1s in the automotive space, to provide a safer and more comfortable future of driving, both in the manual cars, that are the current cars, but also in the autonomous driving, so in the automated cars that will come in the near future. So what is our product portfolio? How do we support our mission? As you know, we have been building consumer devices since, I think, more than 25 years. And since 10 years, we also entered the automotive market. And our product portfolio includes digital maps, connected services, and, of course, navigation software. So these main 3 blocks are also spread into more details. So for services, for instance, we have, of course, our traffic, but also our online search, our electric vehicle charging station services. For maps, we have the standard definition maps that are used for the navigation, but we're also working and building already the maps for the automated driving. And as I told you, we have a navigation software that includes a navigation engine and an automotive HMI on top of that. I will go back on that one in a bit. So what is one of the main trends, together with the other that I already mentioned that we see, is that we, as people, we always want to be connected to the digital life. So how many of you, I think all of you, actually are texting with a friend, and when they enter the car, they just want to continue doing that. So they wait every single moment the car stops, maybe not even that, not even stop at the traffic light, to just keep texting, right? You want to keep, maybe you keep your smartphone on the steering wheel while you drive. I think it's a common case. But this is also the way that we as product creators, we perceive the reality. And it's a kind of a trap, right? Because as product creators, we want to satisfy our users. We want to make them happy. And so we are tempted to bring the digital life also in the car and to basically do whatever the user wants. But we should take some extra responsibility. And as product creators, we need to also consider some extra challenges on that. Because all this technology and all these basically brought-in devices that we bring in the car bring also a lot of distraction. And we know that the visual and mental attention is a key to safe driving. especially in complex contexts when you are, for instance, surrounded by traffic. And I just want to mention that the recent research from the American Automobile Association revealed that 29 out of 40 infotainment systems released in 2017 brought a lot of distraction, brought a lot of cognitive load, as in the user experience term this is called. And in order to perform a simple task, a user could take up to 40 seconds. 40 seconds at 50 kilometers per hour are enough to drive 5 football pitches. So just imagine what happens if you get distracted while you're performing a task, and at the same time, you have to drive. So this is why, as product creators in the automotive space, I believe we have the responsibility to step up and take decision on how to fight against this driver distraction. So at the same time, we see the driver distraction as a problem, but at the very same time, as I said, also the infotainment systems are in general becoming more complex in terms of number of screens that are in the car, in terms of, for instance, the number of pixels available. So screens are becoming more, but also they contain more information. And of course, as a driver, you are surrounded not only by the screens, but also you are surrounded by other kind of technology, like, for instance, the voice recognition. All of them have a good target, so they want to improve the user experience. But if you put all together, they could actually have a very dangerous impact on the life of the driver. So how do we deal with this kind of two competing trends, like driver distraction versus increase in technology? So first of all, we need to understand which information is key at which time. As a navigation supplier, as a navigation developer, product developer, we need to understand that not all the information that we throw to the user has the same importance at the same time. So for instance, if we talk about information about planning a route, so for instance, selecting a destination or browsing the map, that information is important, but has no real priority. So in our opinion, that information could be shown in the center stack. But if we talk about anticipation information, so for instance, notifying the user, notify the driver that the highway exit is in 2-3 kilometers ahead, that could be a good information to be shown maybe in the cluster, because it is in the front of the user, but it is not such a priority. It is an anticipation of some action that the user will have to take. But then there is also another kind of information. It's the priority information, the information that needs to be treated immediately by the driver. So for instance, if you are approaching a traffic incident too fast, so it could become also very dangerous for that. Or for instance, if you are approaching a safety camera and your speed is too high again. In that case, probably the HUD, so the heads-up display, is the best suited place where to show this information. But also we see that there are passenger displays, and for them, probably the best information that can be shown there is more like informational. So it's about when we arrive, so the expected time of arrival, or how much traffic there is on the route. So we need to take all this into account when creating a complete user experience for the in-car navigation. For the navigation of today, but not only, because we're also considering how the navigation will change when the automated cars will come. Because the navigation that now has a guidance task towards the user will become more an informative way to tell to the user the car is about to change lane, or is about to leave the highway, or about to enter the city. So how do we take all this into account? Let me give you some insights about how the software stack is built. I know most of you are engineers, so it's basically a layered software. where we have the navigation engine that we call NavKit, and that provides the primitives, so the basic function of the navigation, searching, planning a route, browsing the map. And then on top of that, we have built the automotive HMI, that we call it reference UI, that is built in using the Qt framework. Some more details about our HMI. So it is as I said, it's a 2 layers HMI. So the first layer is the map rendering part, and you can see in the picture on the guidance view, you have the map that is quite prominent in the screen, but also at the same time you have all the different components like the buttons and let's say the bubble on the top that we call the next instruction panel, and the route bar on the right, and the current street bubble on the bottom. These are all built with Qt, together with all the screens that compose our navigation HMI. So you see here an example of the main menu, where of course you can still see in the background the map that is running by itself. And there is also an example of the search screen, where in this case the search results are shown into 2 different columns. So let's go a little bit more in details, and I will tell you also how our navigation HMI interacts with the other system. So there is, of course, as I said, there is a NavKit. There is a navigation engine that provides the navigation functionalities like search, routing, and guidance. There is a speech system that, as you can imagine, supports the voice recognition function of the system. It is done outside Qt. There is a graphic system that is used to render the maps on the GPU. There is a touch system for the touch, and there is a display system to manage the 1 or more screens that are connected. So let me go now to one concrete example where we had to think about driver safety and at the same time also embrace the scalability, so the fact that we have to embrace a different kind of infotainment system with different screen capabilities. Some of them can be portrait, some of them can be landscape. So let me give you a little bit more details about our scalable keyboard. So as I said, when we designed that, we had to address 2 key requirements. Be safe for the use in a car, and consider that in many countries using the keyboard while driving it is not allowed, so we need also to block the keyboard. But when you are stopped, anyway, you have to use it, and you still have to have a good user experience of that. So one requirement was be safe, and the other one was to be scalable, so to scale between portrait, between landscape, and between different ratio and different size. So this is a bit how our keyboard is built. So the interesting part is that the keys are defined in an XML file. So it's a file that defines the different keys. And then it gets adapted dynamically to the available space on the screen. As you can see, we defined the key width as a percentage of the screen width minus the border space, so excluding the border space, excluding 2 times the border space. So considering that all the key width, but also the key height is computed based on the actual space that is reserved on the screen, it can scale very well between the different screens. I will show you also during you can see the demo is there, but I will show also a movie afterwards. So let's jump a bit more in how the different keys are defined. So each key is defined with a parameter that is called the label, so the value of the key itself. The superscript, so basically the small letters, so for instance the small 4 that you see in the top right corner, and some pop-up characters that you can basically enable by long pressing the key. All these are defined in the XML. Moreover, each key is has also a shape that is also drawn dynamically with the Qt. And the key shape is defined with several parameters. So we have 2 different radiuses, one on the X side and one on the Y side. We have a parameter that is the border, that it is around 2 pixels in this case, and we have an image that defines basically if there is an image to be shown on the key itself. The background color is also a parameter. It's important to say that we are building the keyboard as a Q widget at this stage, but we are considering moving to QML. But it's a step that will take time, as you know, and we haven't started yet. So, and this is an example on how the keyboard parameters are defined into the XML. So you can see quite some parameters there, but it's basically what I described in the previous slide. All the parameters are basically defined for each keyboard layout. So we have the QWERTY, but of course we have also other keyboard layouts, and this allows to be pretty flexible and also allows us to add new keyboard and to work on our geo-expansion effectively. And I want to show you the video on how it works in practice, if I manage to start it. Yeah, I think it's playing. Yeah, so as you can see, the keyboard scales as well, and the shape of the keys adapt if we are in a portrait mode as well as we are and it is different if you are in a landscape mode. I will be more than happy then to show you in real time also what in a demo how this system works, and in general our automotive HMI that is built again with Qt. And I think this is the last slide. Yeah. Okay. And I want to thank you. And if you have any question, we have still a few minutes to discuss if you have additional questions on this. Thanks. Yeah.
So how come you chose XML instead, for example, QML, as you would have the style, the QML styles?
Yeah. Yeah. So this is a choice that has been done actually historically. So when we started doing the automotive HMI, it was done with the Q widget, and yeah, as you said, it would have been smart to start already with QML. But at that time, we didn't think in that way. So QWidgets were already part of the HMI, were already developed. So we just kept doing that. But it is indeed something that we want to move on. We want to move into QML. One of the reasons is that one, because we will be way more flexible, but also way more customizable, because now customization, so changing the color, changing the shape for a different customer is kind of big work for us. Thanks. Any other question? Yeah?
Yeah, sorry, do you want to use this microphone?
Thanks. Yes, hi.
Hello.
Just one question about the compatibility with the Qt virtual keyboard. Is there any, or is it completely separate?
Sorry, say it again. The Qt virtual keyboard?
Virtual keyboard from Qt.
No, we don't use that. I don't know it really well. So We built our keyboard, and we don't use that one.
Okay.
Will you keep that keyboard in-house, or do you have any plans of open sourcing it or making it a product of its own?
No, the idea is that we keep it in-house. What we are considering, because for some customers, they say, we have already a keyboard, we don't want to use that. And so we are working on getting the input from an external keyboard. And this is also an approach that probably will work best for us, also for some countries with difficult keyboard, like all the Asia countries, China, Japan, and Korea, where the input method is very complex. It's way more complex. So we want to take the input from an external keyboard, but we are not thinking about selling the keyboard by itself.
Yes, a question. Why are you still not using QML? Because now it's one was Qt5 released, I can't remember, and now Qt6 will come, and you are still on widgets. And we have the same situation in our company for some things. And yeah, what went wrong?
Yeah, so the thing is that, you know, this kind of stuff, when you talk about refactoring and moving stuff that they don't show user value, the business is always like, okay, can we do it next release? Can we do it next release? This is, I think that we all share this thing. So this is more an architectural change. I see the advantage of it, and I'm trying to sell it internally as well to convince the business that is a necessary step to be more productive, to be faster, and to also start using, for instance, tools like Qt Design Studio that at the moment we can't really use. Okay.
Any further questions? No? Okay.
Okay.
So thank you for that excellent presentation. Thank you.